Okay, let's jump right into this paper. It's called Scaling Open-Ended Reasoning to Predict the Future.
Hmm.
And the mission here is pretty ambitious. It's about training large language models to go beyond just spitting out facts and become, expert forecasters for real-world events.
Exactly. And to do that, they had to start with the data. They built this huge new data set, OpenForesight. We're talking about 50,000 open-ended forecasting questions.
And all automatically generated.
All automatically synthesized from static news sources, specifically Common Crawl News, which is key all with a knowledge cutoff of April 2025.
Okay. And the training itself wasn't just standard fine-tuning.
Not at all. This is where it gets really interesting. They used reinforcement learning, specifically an algorithm called GRPO, with a totally custom reward function. It's this accuracy plus Brier score combo designed for free-form text predictions.
Right, so it has to be accurate and know how confident it should be. So what was the final result? The payoff?
The payoff is a model they call OpenForecaster 8B. It's a Quinn 3.8B fine-tune.
Just 8 billion parameters.
It's just 8B. And it achieves state-of-the-art accuracy and calibration. I mean, on their held-out test set, it matches or even beats much, much larger proprietary models like GPT OSS 120B.
Wow, an 8B model punching that far above its weight, that definitely gets your attention.
Absolutely.
So let's back up a bit and talk about why this is such a big deal. High-stakes decisions, in geopolitics, finance, all of that, they all depend on looking ahead. And while we have human super forecasters, you'd think LLMs would have a huge advantage here, right? They can process so much more information so much faster.
They absolutely should have an advantage, but the bottleneck has always been the training data. For a long time, LLM forecasting was all based on prediction markets like Metaculus or Manifold.
And what's the problem with that?
Well, a couple of things. First, they're mostly binary questions. Yes or no, will this happen?
Right, a 50-50 baseline.
Exactly. Which gives you a really noisy reward signal when you're trying to train a model with RL. It's just not very informative.
And I'd imagine the most important predictions aren't simple yes-no questions. They're about the things you haven't even thought of yet, the unknown unknowns.
Precisely. The real value is in generating a unique, non-obvious possibility. The paper uses a great example. Instead of, will there be a government change? The question is, who will be confirmed as the new Prime Minister of Ukraine on 17 July 2025?
So the model has to generate a specific name, a piece of text, and then assign a probability to it.
Yes. That's a true open-ended forecast. And prediction market data just doesn't give you that. It's also really skewed,
Yeah.
It overrepresents things like U.S. politics and crypto.
Leaving huge gaps everywhere else.
It's huge gaps, and the volume is just too low to really scale things up. That's why they had to build their own data set from scratch.
Which brings us to the OpenForesight data pipeline. This seems like the core innovation. They built a fully automated multi-LLM system to generate questions from daily news. My first thought, though, is leakage. How do you possibly stop the model from accidentally seeing the answer in an article it was trained on?
That is the million-dollar question. And it's why their choice of data source was so critical. They completely avoided dynamic search engines.
Because articles get updated, history gets rewritten online.
Exactly. You try to backtest on that, and you get future information leaking into your past data. It gives you a totally false sense of performance. So instead, they used Common Crawl News.
Which is static.
It's static. It gives you dated monthly snapshots, so you can be certain that when you generate a question, the answer isn't available in the data from that time period. It's chronologically secure.
Okay, so let's walk through this pipeline. It's like a little factory with different LLMs doing different jobs.
It is. The first model is DeepSeek V3. It acts as the sample creator. It reads a news article and pulls out up to 3 potential forecasting questions.
And it generates the whole package, the question, the background, everything.
The whole thing. Question, background, the resolution criteria, which is super important. It tells you exactly where and when to find the ground truth answer. And of course, the answer itself pulled verbatim from the text.
And then the second model comes in to clean up. Llama 4 Maverick. It's the filter.
Right. It's the quality control. Its job is just to be a ruthless validator. Does the question make sense? Is it actually forward-looking? Is the answer unambiguous and definite?
So it's not generating new information, it's just policing the output of the first model.
Exactly. It's chosen for its ability to follow instructions with really high fidelity. And then it does one more critical thing.
The leakage prevention.
Yes. This is the final editing sweep.
Yep.
If the question or the background text accidentally gives away the answer, like it mentions a person's name, who ends up being the answer, Llama 4 Maverick rewrites that part. It replaces the specific name with a generic placeholder.
So it forces the model to actually reason instead of just doing a string match.
That's the entire goal.
The numbers that come out of this filtering process are just staggering. They started with what, almost 250,000 articles?
Yep. Which generated about 745,000 potential samples.
Then the final data set.
After all that filtering, just over 52,000 samples.
Wow, so a 7% retention rate.
Only 7%. It tells you just how hard it is to create high-quality, non-leaky, open-ended data at scale. They had to throw away 93% of what they generated.
And they proved it was worth it. They found that training without that final leakage removal step actually made the model worse.
It did. It's classic shortcut learning. The model just learns to spot the leaky pattern instead of learning to reason. The model, with all the filters applied, got higher accuracy with only a third of the compute time.
And the data scales. They showed that as they fed more of the OpenForesight data to models like Llama 3.1, the performance just kept going up.
Right. It proves the data set isn't saturated. There's still more to learn from it, which is great news for the community.
Okay, so that's the data. Let's move on to the training itself. The base model is Qwen 3.8b, but the magic is really in the reinforcement learning setup.
It is. The algorithm is GRPO, Group Relative Policy Optimization.
Can you break that down for us? What makes it different?
Well, in simple terms, standard RL can be really unstable. The model can take one bad step and the whole policy collapses. GRPO helps stabilize that. Instead of just comparing the model's current strategy to its last one, it compares it to a whole group of recent successful strategies. If the new update is too much of a wild swing away from what was working, it gets constrained. It helps the model learn without, flying off the rails.
That makes sense. And that stability must be crucial given how complex the reward function is. They couldn't just reward for a correct answer.
No, because then you get a model that's wildly overconfident. They needed to engineer a reward for open-ended text that balances accuracy with calibration.
Let's try to translate their scoring rule into something more intuitive.
Okay, so the model gives a text answer, Y, and a confidence score. If your answer is correct, your reward is basically 1 minus the squared distance of your confidence from 100%.
Meaning, the more confident you were, the higher the reward.
Exponentially higher. If you were right and 50% confident, you get a decent score. If you were right and 99% confident, your score is massive. It's like compound interest on being correctly confident.
And the flip side, if you're wrong.
If you're wrong, you get a penalty that's the negative of your confidence squared.
So if you were wrong but admitted you were only 10% sure, the penalty is tiny.
Tiny. But if you were wrong and you were 99% sure, the penalty is huge. It absolutely crushes models that are confidently wrong.
And the baseline, if you just say, I don't know, with zero confidence, is 0. So it forces the model, to be honest.
That's a proper scoring rule.
Yeah.
But they found that just using this Brier score by itself had a flaw.
What was that?
On the really hard questions, the reward for getting it right with low confidence was almost 0. So the model learned a safe strategy. Just predict unknown with 0 confidence. It did that on almost 40% of the hardest questions. It was basically giving up.
Ah, so it encourages evasion.
Right. And that's why their final choice was a mix. Accuracy plus the Brier score. They added a small, simple reward just for being right.
And that little nudge was enough to encourage it to try on the hard questions.
Exactly. It stabilized the training, boosted exploration, and cut those unknown answers down from 40% to about 4%. It's a much more robust system.
Okay, one more piece of the system. Retrieval. Why did they need ARDA for this?
Well, the model's own knowledge was frozen as of April 2025. To make predictions about events in, say, July 2025, it needed to see new information that came out in May and June.
So ARDA feeds it relevant, timely articles.
Right. Using a Qwen 3 embedding model, it would pull up to 5 relevant chunks of text from the CC News corpus.
And I'm guessing the same leakage rules apply here, too.
Absolutely crucial. The retrieval system was only allowed to see articles published up to 1 month before the question's resolution date. So it's using predictive context, not the answer key.
And did it work?
Oh, yeah. Huge improvements. We're talking a 9 to 18% jump in accuracy just by adding retrieval.
All right, let's get to the main event. Section 4. The final results. They tested OpenForecaster 8b on a held-out set of over 300 questions. How did it do against the big proprietary models?
The results are pretty incredible. A massive win for open, efficient models. On the Brier score, which is really the definitive metric here because it combines accuracy and calibration. OpenForecaster 8B outperforms the much larger GPT OSS 120B.
It outperforms it.
Outperforms it.
Yeah.
And it's highly competitive with models as large as Qwen 3 235B. Again, this is an 8 billion parameter model. The performance per parameter is just off the charts.
And it wasn't a fluke. The method worked on other models too, right?
Right. They trained a Llama 3.18B model with the same data-in method and saw a massive 25% absolute jump in accuracy. So the approach generalizes.
But here's the part that I found most surprising. The calibration improvements weren't just for forecasting.
This is, I think, the biggest takeaway for the whole AI community. They tested the model's calibration on totally different benchmarks. Things like Simple QA, MMLU Pro standard tests of general knowledge.
And what happened?
The training made the model better calibrated across all of them.
Wait, so teaching it to be a good news forecaster made it better at knowing when it doesn't know the answer to a general trivia question.
Yes. It seems that forcing a model to rigorously and continuously assess its own uncertainty in one complex domain, it improves its fundamental ability to model its own knowledge. You are, in essence, training it to be less likely to hallucinate confidently.
That's a huge finding, a potential path toward more reliable AI systems in general.
It really is. And they saw other benefits too, like better long-term consistency. The model's predictions for events out to 2028 became more logically coherent, with fewer probabilistic contradictions.
Okay, but it's not perfect. Where did it still fail? The error analysis was really interesting.
Yeah, two big failure modes stood out. The first was what to do when the retrieved information is incomplete. Instead of just saying, I don't have enough info, the model often defaults to making an educated guess based on its general knowledge. It's a bit too eager to please.
And the second one, the Bayern Munich example, what does that show?
So that reveals this fascinating tension between the model's general pre-trained knowledge and the specific evidence from retrieval.
Right.
The context article mentioned multiple soccer teams, and while it pointed towards Benfica being the answer, it wasn't explicit. So the model defaulted to what it knows best. It picked Bayern Munich.
Because it's the more famous, more prominent team in its training data.
Exactly. It's substituting prominence for evidence. When the specific retrieved context is uncertain, its strong global priors take over. That's a really fundamental challenge still to be solved.
So wrapping this all up, what's the key takeaway for you, for the researchers and engineers listening?
I mean, on a practical level, this paper provides an open source blueprint. OpenForesight, the RL method. It's a concrete guide to building these specialized forecaster models and proves an 8B model can compete with giants.
And on a more forward-looking note,
On a bigger scale, this connects directly to the quest for AGI. Open-ended forecasting is an incredibly hard task. It requires reasoning under uncertainty, actively seeking information, doing proper Bayesian updates to your world model.
all the things we think a general intelligence should be able to do.
All the core skills. And this work suggests that scaling this kind of end-to-end training might be a path to developing those capabilities in a more fundamental way. The fact that they've open-sourced everything should hopefully pour fuel on that research fire.
A really critical step towards AI that can genuinely reason about the future. Thanks for walking us through all of this.
It was my pleasure.